In this video, I'm going to quickly walk you through the iWAN app provisioning from APIC-EM. As we all know, iWAN is an SD-WAN technology from Cisco, which helps you efficiently use your WAN links. So let me just quickly walk you through the lab topology that we're going to use for this demo. So this is the topology that we're going to use. As you can see, that we have an hub site which has a core switch. It has two routers named MPLS router as well as an internet router. Both these routers are actually border routers in the iWAN topology. We also have a dedicated master controller, and we have an APIC-EM which is also connected to the core switch. All these routers are connected via OSPF instance 200, and they are under area 100. The OSPF is already configured, and all these routers have reachability to the master controller as well as the core switch and the APIC-EM. Having said that, let's quickly jump on to the APIC-EM dashboard and see how we can go ahead and provision iWAN using that. We get onto the APIC-EM 1.1.1.130 is my APIC-EM server, and I'm logged into the APIC-EM server. As you can see, the iWAN app on the APIC-EM is an inbuilt app. Let's quickly jump onto the dashboard. So once you log into the dashboard, this is the screen that you're presented with. I'm using 1.2 version of APIC-EM. As you can see, there are a lot of options that are grayed out, and the only option that is presented to you is the hub site. So the iWAN app on the APIC-EM expects you to configure the hub site first, and then follow it up with the branch site, and then you can do monitoring and troubleshooting and stuff. On the right hand side, you can see that there are newly discovered devices, which basically would indicate if there is any PNP process that has discovered any new devices. Once the hub site is provisioned, you will see it in the hub site status. Once the branch sites are provisioned, you will see it in the branch site status. And some of the scheduled jobs you can see when you're running some jobs. So let's quickly go and configure the hub site settings. So we go and click. I'm sorry, I have not created the CLI credentials. So let me go and quickly create that. So I create the CLI credentials that will be used by the APIC-EM iWAN app to log into those devices. Let me also just define a simple SNMP read-only string. I define that. I'll save that. Let me also just increase the SNMP property and the timeout. I'll just use 300, which is the max that I can use, just to ensure that we don't have SNMP timeouts when we actually do the configuration. So jumping back onto the iWAN dashboard, let's go ahead and click configure hub settings, and this is the first page that you're actually presented with. So one of the things that we need to remember is the hub site devices should not be in the device inventory. Otherwise, the provisioning of iWAN fails. The iWAN app expects it to provision it themselves, so it will automatically generate some device inventory attributes and will discover the device and manage the device as part of an iWAN app provisioning itself. This is part of 1.2. It might change the newer versions, but to date this is one of the limitations. So just ensure that your MPLS router or the iNet router and the master controller on the hub site is not already discovered and is part of the inventory in the APIC-EM. The first things we need to mention is the NetFlow IP. So it could be any of the NetFlow collector that you have. So I'm going to use my prime, which is at 1.1.1.46. The prime by default uses port number 9991, and I'll leave it at that. The read-only community string, which is public, I mentioned. Domain name, I'll just mention naruslab.com. The NetFlow destination IP need not be routable. It just needs an IP to be mentioned here in the screen. Even if it is not routable, it will work. So there are some additional stuff that you can actually configure. You can mention the syslog server IP, you can mention the DHCP IP, etc. if you want. But for this demo, we'll just leave it with these settings. So I'm just going to go and say save and continue. And then we're going to present it with a screen which says certified iOS releases. So this is the screen that will be used by PNP agent to push a new iOS device on a branch router when it comes up. As the iWAN, as you can see, for 1.2 we support both the ISO 4Ks as well as the ISO G2s on the branch side. So I'm not going to push any configurations or iOS configuration as part of the iWAN provisioning. So I'm just going to skip this. So I'll just say save and continue. And then we get presented with an IP address prefixing pool dashboard. Here what you need to do is mention the number of remote sites that you're going to have, and then the service provider account. The service provider accounts are basically whether you have MPLS links, whether they have 2 MPLS links or 1 MPLS link or 1 internet link, and so on. So what I'll do is I'll just mention it as 5 and the service provider account as 2. The next step is to basically add address pools. The first address pool when you add is called as generic, and this is the pool that will be used to define all the DM BPM tunnels. So whenever iWAN app provisions the routers, it will use the pool to define all the tunnel addresses. So the provisioning of the tunnel address is based on the number of site count that you have mentioned as well as the service provider count. So ensure you have sufficient address spaces where based on the number of site count that you have actually mentioned. So in this case I've just mentioned 5 and 2, so I'm just going to use a /24. So in your case or in your production network, if you have more than say 100 sites and say have service provider count of 3 or something, then you should ensure that you have a proper addressing space that will be used to allocate all the tunnel addresses. So /24 may not work there. So I'm just going to use 5.0.0.24 as our generic addresses. So all our tunnel addresses from the hub routers and the branch routers will use the addresses from this block. If I go ahead and add another address pool, so now it can, as you can see, it shows a LAN interface address pool. So this is the address pool that will be used at the LAN site. So I'll just use 172.16.121.0/24. So there are 2 ways to define this LAN interface. As you can see, I just mentioned it here as a LAN interface, and if I go and just press it another time, it presents me with another LAN interface. So this is a generic way of defining the LAN interface. What you can also do is define a site-specific LAN address space, meaning when you go and click this, you can mention if the serial number of the branch device, whichever is coming up, is with this particular serial number, and you can assign it a site name and then provide a prefix based on the serial number. So you know which serial number is going to come up from that branch, and you can ensure that only this LAN IP pool configuration gets pushed as part of the iWAN provisions. On one of the branches I'll use the generic LAN interface IP pool, and on the other branch I will use the specific LAN address pool. So let's go ahead and add a site specific pool, and the serial number of the device I've already copied it. This is the serial number of my device. I will rename it as Seychelles. The address pool I'm then going to use here is 116.122.0. The prefix is /24. I can also use a VLAN IDs and the number of VLAN type in terms of what kind of VLANs I need to send. But I will not define any VLAN IPs. I will just send a single /24. I'll basically configure a single /24 on the branch side. I need to mention as 24 and say OK. So this is what we need to mention in the IP addressing pool dashboard. This time I'm just going to say save and continue. So once I do that, I am presented with the service provider screen. Here I'll define the number of service providers that I have. In my topology, if you remember, I have only 2 service provider links. One is the MPLS and one is the internet. So let's go ahead and just define those. So I'm just going to mention this as MPLS, and this is basically a private link. So I'm going to add another MPLS link, sorry, an internet link, and then make it private. You can do a metered configuration on the private link, on the public link, sorry, this should be public. On the private link you cannot do that. In the below you find that there are some QoS class already defined as part of the iWAN app. As I said, the iWAN app on the APIC-EM is more prescriptive and follows the CVD guidelines. We have 6 class, 4 class, 8 class, and 5 class. So if you want to change any bandwidth allocation, you can go ahead and change it, or you can define it in your name. For this video, I'm just going to use those default settings that's available part of the iWAN app, and just say continue. So then we are presented with the hub site configurations. So the iWAN app supports both the hub site as well as the transit hub site. So in our scenario, we don't have a transit hub site. We just go and knock this off. And then you're presented with the screen. As you can see that the hub site, it's saying that there is showing basically a dedicated master controller, and there are two routers which basically denotes the border routers. So if you don't have a dedicated master controller, and if the master controller is being utilized on one of the border routers, you can just go ahead and say no, and the master controller shifts here. But in our case, we have a dedicated master controller, so we'll use that. And then we're gonna press the master controller and just present the management IP that we have. Just before that, what I would like to do is show you that we have connectivity between our master controllers and the border routers at the hub site. So I'm just gonna quickly log into the hub routers. This is my hub MPLS router. It's already been defined with the IP addresses, the passwords, and the SNMP strings, which will be required by the iWAN app. And if you can see, show IP route, it's basically able to find out all the routes which is used to connect to the APIC-EM server as well as the master controller. So I'm just going to quickly ping the master controller, and I'm able to ping that. If I do a show IP OSP of neighbor, you will find that it has a neighborship to 3.3.0.3, which is basically the internet router, and it also has a OSP of relationship to 3.0.0.1, which is the post switch. Now similarly, you can find the iNet router here, which also should have reachability to the master controller. It should also have reachability to our APIC-EM server. If you see, show IP OSP neighbor. This is it also has a neighborship relationship with both the core switch as well as the MPLS router. Just to quickly see what's the OSPF configuration that looks like. This is basically the OSPF configuration. So I'm just gonna define those network configurations of the inter router links as well as the loopback addresses. If you look at the interface details, this is how it looks like. There's no configuration of TMVPN or PFR that's been done on those devices. Okay. Similar is the case on both the master controller as well. So let's go and quickly check configure the master controller. So master controller loopback IP is 3.0.0.4. So I'm just going to quickly validate it. It at a minimum requires the read-only community. The protocol that I'm going to run is telnet for now. And the passwords. And I'm just going to say add device. So it takes a bit of time. It basically tries to poll the device and tries to get the information from the device. So let's just wait. In the meantime, what we can do is basically go ahead and click the border routers and identify and provision those routers as well. So this is one of the border routers, the MPLS router, which is 3.0.0.2. And just do a validate. Once you pass on those values, if the values are same, this is already pre-populated in the screen. So all my credentials are similar on all those routers. So I'm just going to say add device. And as you can see, it's gathering information both from the master controller as well as one of the hub routers. So let's go ahead and do it for the internet router as well. So this is 3.0.0.3. Just do a validate and say add device. So let's give it a minute or so till the time all the routers are gets identified from the iWAN app. As you can see, the color on the router has changed to yellow. That means it is expecting us to do further configurations. So let's go ahead and click this. So it just asks you what is the LAN interface of this IP, of this router. Sorry. This is the MPLS router, and this is the LAN interface that connects back to the core switch. So I'm just going to say this is the LAN interface and just say save. And the moment I do a save, you would see that the color has turned green and with a check mark, which means whatever configuration was expected from an iWAN app perspective, all those configuration has been done for the router. Let's go and similarly do that for the MC. It asks for the LAN interface, and this is the LAN interface for the master controller, and that also has turned green. Similarly, let's go ahead and do it for the internet router. Just going to do a save. The moment you have done the configurations on these routers, you would have noticed that there is a plus sign that has come here. So before that, let's go ahead and define the links as well. So this is the router which is going to connect to the MPLS link, and this is the router which is going to connect to the iNet link. So let's click the plus sign here and say which is the interface that's going to connect to the WAN side. So this is the interface that's connecting to the WAN side, and the default gateway is the next hop PE, which is wide at 2. So I'm going to mention the primary bandwidth is about 50 megabits per second. I'm going to use a default 4-class model. You can use the either 4, 5, 6, or 8. I'm just going to do save, and that's a check mark on this link as well. Similarly, do it for the iNet router. Gigabit 0, Gigabit Ethernet 2 is the interface, and it has a default gateway to 6.2. And if you have a NAT in place, most of the time you'll find that the iNet router is placed in some sort of a DMZ where the traffic heads to a firewall where the interface IP gets NATed. And if you're having such a scenario, you need to enable the NAT and mention the NAT IP address, so that when a DM VPN tunnel is formed from the branch, it uses the NATed IP address of that box rather than using the primary address. So in our case, we don't have any NAT involved, so I'm just going to leave it blank. And I'm going to mention the bandwidth as, say, 20 Mbps on the internet side. As you can see, the service profile is unhighlighted here. You cannot change it. It's by default showing you a default 8-class model, but since it is a internet link, we don't have control on the QoS on an internet link, so it just doesn't matter whatever class it is. So just going to go and press save, and then I'm going to press this plus here. And what it does is basically ask you what is the routing protocol that you're running on the device. So I'm just going to say I have running OSPF. It auto-populates the area number. It identifies that OSPF 100 is seen on the device. And it also auto-populates what are the prefixes that are seen on the LAN side. And that comes from the OSPF topology. So it, as you can see, it basically identifies all the router-to-router links, some of the LAN interfaces. And it also should identify one of the interface, which is the LAN side interface 172.120.0, because I've advertised this as part of OSPF. If you quickly go back to our topology, you can see that the data center LAN is 172.120.0, which is advertised by this core switch. So APIC-EM identifies it from the OSPF topology and then populates it here. So you can see it has populated most of the prefixes. If you want to add any prefixes that needs to be configured as part of a data center LAN, you can go ahead and add a few more prefixes here. But for this demo, I think all our prefixes are already available. So I'm just going to go and say save. So as you can see, every portion of this iWAN app provisioning page has a check mark associated with it. So that means all the necessary configurations have been completed. So we'll just go and say hit save and continue. So I'll give you a summary in terms of what it's going to do a configuration. It says that 3.0.4 is a master controller, the hub border router. This is the hub border router. What is the management IP, and what's the LAN interface, and what's the WAN interface, and what's the WAN IP address. And similarly for the hub border router, which is the internet router. And then you can actually push this configuration across either now, or we can actually schedule it to be performed at a particular time. So I'm just going to say apply now and just say continue. So once you do that, you will find the configuration has been successfully submitted from the iWAN app. So now you can see that these configurations will be pushed across to all those devices. And you'll find that in the dashboard, the hub site status shows that one device is being provisioned and it's in progress. So let's quickly jump on to the consoles of all the devices. I will open it here, and you can see there's a lot of configurations that are going on in those devices. So these are the two devices are the hub MPLS router. This is the hub MPLS router, which is one of the border routers. This is the hub iNet router, which is another border routers, and this is the master controller. As you can see, APIC-EM is trying to push configurations across to all these three routers. What it basically does, it enables SSH. It pushes a certificate across to those devices. It configures DMVPN on these devices, and then it also configures PFR v3 on the master controller as a policy engine. So we're just going to wait till all the configurations are complete, and then we can see what configurations were pushed as part of the iWAN app. So let's quickly go to the status dashboard, and it shows that the hub site is being provisioned, right? So let's wait for it to get provisioned. It shows in progress, and once it gets provisioned, it should show as provisioned. As you can see, the status has changed from in progress to provision. So the hub site is completely provisioned here. So let's go and quickly check the device configurations. So let's quickly jump on to our master controller first, and just do a show IP in brief. This is not, as you can see, it has actually defined a loopback interface, which will be used as the loopback interface for the domain configurations as part of the DMVPN tunnel. So we'll just quickly do a show run, and you can see that the PFR v3 configurations is done. Sorry, it says domain 1 as part of the default VRF. It's the master hub. It uses the loopback interface that it's created. It creates some right side prefixes, and it then creates a lot of it creates classes. I'll show them again, and you can see it has created the browsing sequence, database sequence. It's basically creating those PFR v3 classes for applications to be identified and the path to be controlled. And then it pushes a certificate. This certificate is basically used to authenticate the DMVPN tunnel. The IPsec uses the certificate that's being pushed from the APIC-EM server for authentication. That's it. It defines the prefix list, the data center prefixes, which is basically the prefixes that are on the data center side. It also would push the prefixes that are on the enterprise side. If you see, the major difference between the DC prefix and the enterprise prefix are the prefixes that we actually defined on the branch side. So 122 and 121 were part of our branch prefixes, and which gets defined as an enterprise prefix here. And on the DC prefix, it's just the data center side prefixes. So just quickly go ahead and check one more thing as part of our DMVPN and PFR v3. Sorry. So as part of the PFR v3 configurations, there is a SAF configuration that gets done, and this is auto-generated, auto-configuration. So you can see that the master controller is able to talk to both the border controller. This is the IP addresses which we define on both the border controllers, and it's able to have a successful SAF EHR relationship, which is required for PFR v3 to work. So let's quickly jump onto the MPLS router and just do a show IP in brief first, and you can see that it has got some configurations as part of DMVPN. It has defined a tunnel 0. The tunnel 0 is basically an auto tunnel generated between the border routers. So it is the tunnel that has been established from the MPLS router at the hub to the internet router at the hub site. The tunnel 10 is the tunnel, DMVPN tunnel, that is actually going towards the MPLS service provider. And similarly, if you look at the internet router, sorry. You will find that the tunnel 0 is basically again the auto tunnel that's between the internet router and the MPLS router, and there's a tunnel 11 that is configured, which actually leads to the internet service provider. Just do a quickly show run. It will find that you have a domain configuration for PFR, you have a certificate, and you have all the class maps for performance routing defined, and you have the entire DMVPM configuration here. So on the tunnel, you can see that the NHRP configurations are there. I'm sorry. I'll do a show run again. Tunnel 11. So you can see all the NHRP required configurations are there, which is part of the DMVPM. And similarly, on the MPLS side, you can see it on tunnel. Okay. So this is the configurations that have been successfully pushed from the APIC-EM. So one of the things that we need to do is quickly go and see the map. As you can see, the location is showing as unknown. So let's fix that as well. So just quickly go to the map. By default, the hub site just goes and shows somewhere in the United States. Let's quickly move it to India, somewhere in, say, Mumbai. So I'm just gonna switch the edit mode and then move this hub site to somewhere in India. I'm just gonna double click and zoom it over India. And just push this hub site somewhere in Mumbai, and then I'm just gonna switch off the editing and just go back to the list, and I should say that it's already taken the location as Maharashtra from the map. So it basically shows you a geolocation map. Go back to our iWAN homepage and provision our branch devices now. As you can see, once the hub site is configured, you have all the other options highlighted now. On the hub site status, you can see that there's a one hub site which has been provisioned, and then it has also configured some of the application categories, application policy groups, and path preferences. We'll come to that in a little while. So let's go ahead and just complete our branch site provisioning as well. So let's go ahead and click this branch site here. And then it shows that there are 0 devices that are newly discovered, right? So what we will have to do is use PNP's bootstrap information to ensure that the device reaches back to the APIC-EM, and then let the APIC-EM discover the device as part of the PNP process, and then we can go ahead and provision those devices. So I have console to both of those branch routers. So let me just quickly log on to the router, and as we have seen in a previous PNP video, I'm just gonna quickly define a PNP profile to go and talk to the APIC-EM server. Let's say APIC-EM transport HTTP IPv4, the APIC-EM server IP address, and the port 80. So that's it, and similarly I'll do it for branch 2. Transport HTTP IPv4 port 80. Let me just quickly check if I have the interfaces up here. No, and that's the reason it's taking a little bit of time. Let me quickly ensure those interfaces. And add a default route out to the internet. As you can see on the other side, those configurations were already present. It was basically the configurations, the only configuration that the device had was the IP addresses and the default route to the internet, and the internet was able to route the traffic back to the APIC-EM. And as I've shown it in the last video, The clock update means there is a successful communication between the APIC-EM server and the router. So let's see, similarly, do we get a response on the branch 1 router as well? And yes, as you can see, there is a system clock update, which means there is a successful communication from both the branch routers from a PNP perspective to the APIC-EM. So let's just quickly go back to our iWAN dashboard. We still don't see any newly discovered devices. It may be because the device is still being discovered. It is trying to get more information on those devices. So if you can just go to our plug and play app and see if there are any devices that it's found out. Yes, it has found out 2 unplanned devices. And we'll just see this. It has identified those serial numbers. It has identified those IPs, and it says as unclaimed. We don't want to claim it. We just need to see if the iWAN dashboard also discovers those 2 devices. And it's discovered one of the devices. It shows 1 newly discovered devices. So just wait for a few more minutes till the time it actually discovers both of those devices, so that we can go ahead and provision those devices. So yes, now it has 2 newly discovered devices. Let's go ahead and click that, and then you have both of these 2 routers. So you can click one of the routers. I'll click one of the routers and then provision it, because those are 2 different branch routers. If you have 2 routers in one branch, and then you'll have to simultaneously select both the routers and then say provisioning. So let me just quickly show you that. So if you click one of the routers and then say provisioning, it shows unknown. So let me just tag the device. As you can see, there's one more important thing. This serial number we had actually entered as part of the LAN pool description. So it's already taken the name as seashells. That was what we had defined. There's an unknown site name that's appearing for the other device. So let's just quickly click this. And what we mentioned was, I think, Zurich. We'll say save. And let me just say I'll provision the first branch site. Okay. So the moment you see that you get 2 types of configurations, the 1 router configurations and the 1 router with 2 WAN cloud configurations. So let's just quickly go back, and then I will again click this. And what happens if I select both routers and say provision site? The problem is it won't allow me to do that because the site names are different. So if you have the same site names, it will actually show you two routers as part of the single branch. Okay, so let's go ahead and quickly provision one of the branches, which is branch 1. I'll use a configuration of single router branch with 2 MPLS clouds, and that's what our branch look like. It's a single router which has 2 links, one to the MPLS and one to the internet. So going back to the dashboard, I click this, I click here, and then we need to furnish some information as we did for the hub site, right? So the site name is already pre-populated. That's what we saved. Geolocation is, again, we need to mention, and this is required because this is what is being used to display the site on the geo map. So you need to mention POP to connect is just hub because we have only one POP. If you had a transit hub, it will also show the transit hub on the drop down menu. So let's select WAN. So we have one WAN, which is MPLS. Let's treat this side of the link as MPLS and this side as internet. And then we go ahead and click this plus sign here, and then tell the device what interface that it will use to basically connect to the WAN. So the gigabit Ethernet 1 is what is being used to connect to the MPLS provider, and this is the default gateway. The download speed is say 50 MB, and I'll use a default 4 class because that's what we used on the other side. Just say save. Similarly, we'll configure the internet leg. By default, the internet will show us as DHCP, but we'll use a static IP address, and it has already discovered that it's the WAN IP address that it used was the Gigabit Ethernet 2 interface, and it's the gateway address. Since it's an internet link, you generally have differential upload and download speed, so it basically gives you an option to mention both the upload as well as download speed based on what based on which the DMVPN configuration and the NHRP bandwidth configurations happens on the tunnel routers. So what we will do, just for the sake of simplicity, we'll just mention upload and download as 20. I'm just going to say save, and then it comes as the LAN. So this LAN tab is required because we didn't mention any we didn't mention any LAN configurations at the time. We presented we only defined a generic LAN interface, right? So that's what it mentions. You can choose the interface that will be used as a LAN interface. Both the Gigabit Ethernet 1 and 2 has been used for the WAN, so that is the only interface that's left. Since it's a branch site, it also you can actually define different types of VLANs that it's going to use and the VLAN IDs. But for this demo, I'm just going to use a single LAN interface without any VLANs. If you configure VLANs, it configures that particular port as a .1 queue trunk with the particular VLAN IDs. So I'm just going to quickly remove these VLANs. Okay, I'm just going to say save, and you can see that all the required configurations has been completed. So I'm just going to say apply changes, and it'll go show me a summary in terms of what will be configured on the device. As you can see, this is the interface that will go to the MPLS link, this is the interface that will go to the internet link, and there is no DHCP configured on the branch router, and the LAN interface is basically the Gigabit Ethernet 3. And as usual, again, you can schedule this to be applied at a specific time, or you can apply it immediately. So they submit, and are you sure to apply the changes? I'm saying yes. And as you can see, this hub site is being configured now, and there will be a configurations that will happen on this router. I have a console to that router as well. So in the meantime, since this is being configured, let's go ahead and provision our other branch site as well. So just quickly go to the dashboard, we'll click this router, we'll say provision. Again, shows you two options. We'll use this option, and you can see the site name is auto populated from the trade. Let me give it a geolocation name as well. Pop to connect to sub. One of the WANs is MPLS and one of the WAN is iNet. Let's quickly define the MPLS link. 2.6.5 is fine, and let's define this as say 50 MB again. Let's make it 30 this time, and make this as 4-class model. Okay, similarly define iNet. I'll use Gigabit Ethernet slash I think I made a mistake. Let's quickly get it here. This is Gigabit Ethernet slash 1, which is the MPLS side of the link. Make it, save it. On the internet, it is Gigabit Ethernet 2, but using a static IP. And the upload, let's say in 20, and download is 20. So as you can see, when I press the LAN tab, we were presented with different VLAN information in the previous branch configurations. Here it does not present me with any options because we had predefined the IP addressing that needs to be used when this router with this particular serial number gets identified by the iWAN app. So we're just going to go and say save. All the necessary information is done. I'm going to hit apply. So this is the summary of what information will be pushed onto the routers. Let's go ahead and submit. See, both the routers are getting configured. One is in the pending state, one is in progress. I think it does it one by one. So let's quickly see. This is the Zurich router, and this is the Seychelles router. So the specific routers, a lot of configurations have already been done, and the configurations on the Seashells router is just getting started. The SSH configurations is the first step as part of the iWAN provisioning. So just wait till both the branches are provisioned. The branch 1 router has been provisioned, so let's quickly go and check whether it's been configured properly. So this is a branch 1 router. It shows on the dashboard that it's been successfully provisioned, and then we'll go to the branch 1 router. And that's it. So it's provisioned as well. It has provisioned all the loopback interfaces, the tunnel 0 address, which is just the auto tunnel, and then the tunnel 10 and the 11. 10 goes to the MPLS service provider, the 11 goes to the internet service provider. And as you can see, we'll do a quick show run. I'm sorry. So yes, just quickly check the running configurations. As you can see, it defines the domain configurations, which is required part of PFRv3. Now you can see that this is the local master, and it also reaches out to the hub master. Because it's a branch router, it accesses both the border as the border router as well as the master router for the branch. It also talks to the hub branch. Then you have the PKI configurations. Then you have the performance monitor configurations, and the required tunnel interface configurations as well. Okay. So let's just quickly check the EHRP SAF status from the branch as well. And yes, it can talk to the hub router master controller. That's what we wanted. So another thing what we can see is whether it has received all the information from the hub side in terms of policies. So just quickly to show domain 1 master policy, and as you can see that as part of the PFRv3 registration process, this router, the branch, has received all the policies that were actually pushed across to the master controller of the hub. So now what we'll do is quickly quickly log into the master controller and just see whether we are manipulating any traffic classes. In terms of the dashboard, if you see, there's no path preference set, and most of the applications, almost all the applications, are using MPLS as the preferred path. So just quickly see that. Let me go to the master controller and do a show domain 1. Sorry, master traffic classes. And you can see I have an HTTP traffic that is running from the hub side to the branch side, and as you can see, that application HTTP is identified from the N-bar configuration that gets pushed, and it is showing that it is primarily going via MPLS, and the backup channel is internet. So how we can manipulate that as well? We need to go to the administrator application policy. We'll click that. Here, if you see, there's a lot of applications that are listed. You can actually add your own applications. You can define your specific application policies, and then ensure what kind of treatment has to be given to for that specific application policy. So let's go to the application policy. Now you can see that all the applications are basically categorized into 3 categories. One is the business relevant, irrelevant, and default. On the business relevant side, we have categorized all the applications by using MPLS as the primary link. So you can see that the business and product tools, emails, and everything is actually going via MPLS. Now what we can do is change the browsing traffic to go via internet rather than MPLS, and just to see if how this changes the traffic behavior from the hub site. So we'll just quickly go and do that. We just have to click this arrow mark here and just change this to iNet and this to MPLS. Just before doing that, let me just go and show you what's the current policy for browsing. quickly check that. This is where it should be defined somewhere. Let's see, browsing. This is class, this is voice video. This is email. I think I missed browsing somewhere. Okay, the sequence 20 is class browsing, and you can see the path preference is MPLS and fallback to INET, and that's the reason that when you do a traffic class summary, it shows that the primary channel is the MPLS channel and it's backed up by the INET. So what we'll do is go here and change the preference for the specific application. Browsing is mostly HTTP, so we'll change this to INET and MPLS and just do save. And then you just need to go and say apply configs. So it'll just give you a summary in terms of what you're trying to do. Is it has identified the category browsing, and what you're going to do is change the primary allocation to internet link, and the secondary is a backup on the MPLS link. So just say apply now. And again, you can see that the hub sites getting provisioned here. And we'll again check on the router. Once it's provisioned, we'll check on the router whether the path preference has been changed. So we didn't do anything by configuring or doing any configurations through the CLI. All of these changes can be done from the APIC-EM console itself. And says provision, so I think, and you can see that there's a console logs that APIC-EM did do some changes to the configurations. So let's quickly do a show run, and it was sequence 20. This was the browsing sequence, and you can see that the path preference has actually changed from MPLS to INET. So INET or the internet link has become the primary path for browsing traffic. Now if you see the dashboard, now the application path preference is showing both of the links. It's showing predominantly MPLS for most of the business relevant traffic, while INET link is also used for the browsing traffic, right? And that's what it shows. So let's quickly go and do a configuration or integration of this APIC-EM with Prime, so that we can do a proper monitoring of that of the application. So let's go to administer policies. As you can see, the application in the application bandwidth scenario or the tab, it shows you that you need to configure private credentials. So just click that and say, and it will ask you what are the prime infrastructure settings that we have. So I have a prime infrastructure which is running at 1.46. The username and the password, and that's the only step that is needed on the APIC controller. Now there are a couple of steps that is needed on the prime infrastructure. So let's quickly configure those as well. Quickly log on to the prime infrastructure. The first thing we'll do is just see if there are any network devices. Let me go to the network devices inventory. There are no data here. So the first thing that you need to do is go to administration and add the APIC-EM controller. So we'll go ahead and quickly add it. The APIC-EM controller is 130. Confirm the password. And that's it. This is added. And you'll see that the server addition has been successful. So once you've configured the APIC-EM controller, you need to go to the job dashboard, the administration, and you will see that there are two jobs that got added as part of the APIC-EM controller addition to the Prime infrastructure. As you can see, there is an APIC-EM site sync. It shows success, and there's a PNP status polling. You can actually go ahead and run this again if you want to. And what it does is basically, as part of the site sync, we didn't add any devices onto the Prime. The devices that were added to the inventory on the APIC-EM gets added onto the Prime infrastructure as well. So just first let's go to the APIC-EM and just see how the device inventory looks like. So you can see that the APIC-EM, we never did any discovery on the APIC-EM. As part of the iWAN provisioning app, it actually added all the devices. It's basically the hub MPLS router, the hub MC, the hub iNet, and the hub branch 1. Branch is still getting provision. It gets added across to the APIC-EM inventory, and this inventory will get replicated or synced with the Prime infrastructure. So let's just go to the Prime infrastructure and just quickly check. And you can see that all the 4 devices are automatically populated into the Prime infrastructure. Now, one more important step that we need to do is go to services and then go to endpoint association. This is necessary before you get any application bandwidth and monitoring policies from the APIC-EM and Prime infrastructure. So just add locations, and we'll see hub. So all locations will say hub. Hub was 116.120.0/24, and you can mention the data source as hub 1, say master controller. Save. You can also add another location, which was in our case Zurich. This again gets populated automatically. 121.24, and you can see the data source was actually coming from the branch went. It was safe. So these are the 3 important steps that we need to do. One is to add the APIC-EM controller, and then the second thing is to check the job dashboard whether we have an APIC site sync job running on the Prime infrastructure, and third is the endpoint association. So once this is done, let's go back to our APIC-EM and go to the iWAN app. And click on this. As you can see, it was actually showing please configure Prime credentials. Now it actually shows you the application bandwidth. So once you go and click this, you'll find that this is able to detect all this required information. The traffic was actually flowing through MPLS, and then it dropped down. It'll slowly come up, and let's take it to the last one. It will show you how the traffic was. So you can actually even go around and click here. It shows you what's the amount of traffic that was pushed across at this point of time. All these things are coming from Prime. It's visible on the APIC-EM itself.